Alright, so this video is just to review what we discussed today in class with the laws of exponents, as well as give you some more examples that we could not do in class. So I'm going to go through these first few slides fairly quickly. I'm just going to put them up there so that you can see them. If you need to pause at any time to copy something or to look at something, feel free to do so. We're looking at monomials, which are numbers, variables, or a product of numbers and variables. The base and the exponent and the power are all important terms that we're going to be looking at as we go through the rest of laws of exponents. We started off talking about product of powers. If we have the same base, we add the exponents. And here are a couple of examples that we did in class. Again, if you need to pause at any time, feel free. Power of a power, if we have some power being raised to another power, we multiply the exponents. Power of a product is similar to the distributive property where we are distributing an exponent to everything inside of the parentheses. Okay, here are the examples that we did not do in class. I have multiplication across this entire problem. The very first term has an exponent of 1, even though there's nothing written there. I'm multiplying to the same base, so I can add the exponents, add the 1, the 4, and the 6, so I get x to the 11th power. Again, I'm multiplying across this entire problem. I can split this problem up using the commutative property and put similar terms together, like terms together. Well, not really like terms, but similar terms. Put the coefficients together, put the a's together, and put the b's together, and then multiply. 4 times 9 is 36. A to the 4th times a squared. Add the exponents. I have a to the 6th. And I have b to the 1st power times b cubed is b to the 4th power. When I'm multiplying and the bases are the same, I add the exponents. I'm raising a power to a power and then to another power. So I multiply all of these together. Multiply the 3 times the 2 times the 3. 3 times 2 is 6. 6 times 3 is 18. So this is 2 to the 18th power, which I believe is 262,144. Is the same answer as a problem we did today in class. I have, this one uses power of a product. I have a 2 outside of the parentheses that I need to distribute to each piece inside. So I have 3 squared, y to the 5th squared, and then z squared. 3 squared is 9. Y to the 5th squared, I multiply the exponents. Y to the 10th power, and then I have the z squared. I'm multiplying all the way across, so I can separate the pieces out. Put the coefficients together, put each variable together. 4 times 12 is negative 48. M times m squared, this is m to the 1, so this is m cubed. And n squared times 1, this is n cubed. All right, well, you can see down at the bottom, let me erase that really fast, and then we'll actually go through this problem. It's the same problem. I'm not sure why it shows up twice. So let's just look at the top one. I have a power of a product, so I'm going to take the 3, give it to each piece of the first binomial, sorry, and then take the 2 and give it to each piece of the second monomial. I've got negative 2 cubed, v cubed, cubed, and w to the 4th cubed. And I'm multiplying all of that times negative 3 squared, v squared, and w cubed squared. Let's simplify this down some. Negative 2 cubed is negative 8. V cubed is v to the 9th. Multiply the exponents. And v to the 4th cubed, sorry, w to the 4th cubed is w to the 12th. Negative 3 squared is 9. V squared, we leave the same, and w cubed squared is w to the 6th power. And now I can multiply and add exponents. I can do the negative 8 times the 9, the v to the 9th times the v squared, and the w to the 12th and the w to the 6th. So negative 8 times 9 is negative 72. V to the 9th and v squared, add the exponents, that's v to the 11th. And w to the 12th plus w to the 6th is w to the 18th. Break it up piece by piece to help you better understand this type of problem. And I believe those are all of the multiplication ones. Yep, those were all of the multiplication problems. Let's take a look at the division laws of exponents. When I have quotient of powers, if I'm dividing and the bases are the same, I subtract the exponents. And here are some examples that we used in class. Power for quotient is just like power of a product. If I have a quotient inside of parentheses with an exponent on the outside, I give that exponent to both the numerator and the denominator. Again, a few more examples. And this is where we started to leave off with 0 exponent. Anything raised to the 0 power except for 0 will be 1, and we use this pattern to help us figure that out. And in the next class, we will talk more about the negative exponent. But for negative exponent, I'm going to take the reciprocal of only the stuff that has the negative exponent, and then change the exponent to a positive. So 5 to the negative 2 power, this is really 5 to the negative 2 over 1, so when I do the reciprocal, it becomes 1 over 5 and make the exponent positive 2. So this is 1/25. And 6 to the negative 3, I do the reciprocal, so it comes up. The 6 to the negative 3 comes up, and it becomes positive. That's 216. So looking at these two examples, I have c to the 5th over c cubed, all of that's being raised to the 0 power. I could figure out that inside it's c to the 2 power, or c squared, but the fact that I have a 0 as the exponent tells me that all that I need to know is that it is 1. B to the negative 3 c squared over d to the negative 5. The b to the negative 3 will have to come to the denominator, and the d to the negative 5 will go to the numerator because I'm doing reciprocals with my negative exponents. The c squared stays in the numerator. The d to the negative 5 comes up to the numerator and becomes a positive 5. And the b to the negative 3 goes to the denominator and becomes b cubed, b to the positive 3 power. These next examples, we'll look at the division properties, but we'll also take a look at the 0 and the negative exponent. So I have 7 to the 8th power over 7 squared. My bases are the same, so I subtract the exponents. 8 minus 2 is 6. Again, pause if you need to as you're going throughout this. I have x to the 8th power, y to the 12th power over x squared, y to the 7th. Look at these separately. I have x to the 8th over x squared. Subtract the exponents because the bases are the same. I have x to the 6th power. Y to the 12th over y to the 7th. Subtract the exponents. And I have y to the 5th power. I have a quotient inside the parentheses and a 3 as an exponent on the outside. So I take that 3 and give it to everything inside of the parentheses. 2 cubed, c cubed, cubed, and d cubed over 7 cubed and z squared cubed. And let's go ahead and simplify this. 2 cubed is 8. C cubed, cubed is c to the 9th. D cubed we leave the same. 7 cubed is 343. 343. And z squared cubed is z to the 6th power. So I do have to use some of my multiplication laws as I'm doing these problems. So with this one, I know that y to the 0 power is going to be 1. So I don't have to look at that anymore. I have y to the 5th times y to the 9th. I add the exponents here. So y to the 5th, or 5 plus a negative 9 is y to the negative 4. I cannot end a problem with a negative exponent, so I'll have to bring the y to the negative 4 to the denominator. Make it 1 over y to the 4th power. I could have done the same problem by bringing the y to the negative 9th down to the denominator already, and then subtract, and I would still end up with y to the negative 4. The other way that we could look at this problem, if I expand this out, is that I have y times y times y times y times y over y times y, doing it 9 times. 7, 8, 9. And I can cancel out some things here. I have y over y, y over y, y over y. Those each make 1. And I'm left with 4 of these y's in the denominator, which gives us the 1 over y to the 4th power also. So I could subtract my exponents by saying 9 minus 5 is 4. And the fact that I have more y's in the denominator, that's where my y's are going to end up. So both methods will give me 1 over y to the 4th. Do whatever makes the most sense to you. 13 to the negative 2, that has to go down to the denominator. So I have 1 over 13 squared which is 1 over 169. C to the negative 5 over d cubed, g to the negative 8. Move my exponents. C to the negative 5 has to go to the denominator. G to the negative 8 has to go to the numerator. So I now have g over 8, g to the 8th power, I apologize, over c to the 5th, d cubed. Negative exponents, I need to do the reciprocal. Again, take this problem piece by piece. I'm going to start off with the negative 5 over 10. That's negative 1/2. I have p over p to the 6th. This is p to the 1 power. I can subtract the exponents. I'm going to do 6 minus 1 is 5, and there are more p's in the denominator, so p to the 5th is in the denominator. And with the q's, I have 7 over 3. 7 minus 3 is 4. There are more q's in the numerator, so I have q to the 4th power in the numerator. If it makes more sense for you to subtract them straight and say that you have p to the negative 5 and then q to the 4 and then bring the p to the negative 5 to the denominator later, do it that way. Whatever makes the most sense to you. Just a couple more. Again, this problem you could do a couple of different ways. I'm going to first distribute my 3 in the numerator and my negative 2 in the denominator. C cubed, d to the negative 6 over c to the negative 8, d to the negative 18. And because I don't like working with negatives, I'm going to go ahead and move things. So I'm going to move the c to the negative 8 and the d to the negative 18 to the numerator and the d to the negative 6 to the denominator. I just don't want to deal with a lot of negative exponents. So I have c cubed, c to the 8th, d to the 18th in the numerator, and then d to the 6th in the denominator. C cubed times c to the 8th is c to the 11th. D to the 18th over d to the 6th. 18 minus 6 is 12. That's d to the 12th. If you would like to move that whole denominator first, you can move that whole thing up, then square it. You could subtract and say 3 minus a negative 8, that's 3 plus 8. And negative 6 minus 18, minus a negative 18, and make that a 12 there, and go straight to the answer. It's just whatever makes the most sense to you. And I believe this is the last one. And save the easiest one for last. I have 4 m to the negative 3 n to the 5th to the 0 power over mn. Anything to the 0 power is 1, so this is 1 over mn. So again, those last problems were new. I had not shown those to you, and we had not finished negative exponent in class. We will finish negative exponent in class and do more practice with it. Please go back and re-watch this video if you need to, pausing and making sure that you understand how to use each of the laws of exponents.